So now that we've practiced with asking questions, the way to RATATAZ any subject, this is what we're going to learn, is how to RATATAZ any subject, not just chemistry, is to ask and answer your own questions. And I am going to teach you how to do that. So pull out your lab notebook and set it in front of you and grab a pen or a pencil or something and turn to the first page. Set up your experiment. So one of the things I like to think about when I'm getting ready to do an experiment is, am I going to get my hands dirty or am I going to get my clothes dirty? In this experiment, we're going to use some water and we're also going to use some paint. So if you're wearing your favorite jacket or your favorite shirt or a pair of pants you like, go ahead and switch those out or put a big shirt that you don't mind getting dirty. I'm going to take my jacket off and I'm going to put a lab coat on. Okay, now I'm ready to go. I've got my lab coat on. Hopefully you have some clothes on that you don't mind getting dirty. So let's dive in and find out what is break the paint. So setting up your experiment. Remove everything from the box. So just make sure you've removed everything from your box if you haven't already done so. Gather all the items that will be used in this experiment. Check off the items you have. Watercolor paint set. Check. Test tube holder. Check. Brown paper. Check. In the starter kit, there were beakers. Check. A graduated cylinder. Check. Test tubes. Got those. Check. Pipettes, transfer pipettes. Check. Scissors, here, and safety glasses, here. Great. Not in the box, we have some water, here, and some warm water, here. So grab some water, if you haven't already done so, put them in the beakers, or you can just put them in a cup, it doesn't matter for now. Check and check. Okay, so it's a great time to open up your safety glasses and put them on. I'm going to keep my reading glasses on because I won't be able to read the pages if I put safety glasses on. Go ahead and put your safety glasses on. We might get splash some water and splash some paint. Okay, so the next page says use tools like a chemist. So we're going to learn how to use some chemistry tools. Science is an adventure. Having the right tools is a big help when you want to be a scientist. So here's a practice to ask some questions, and we're going to do these questions together. What is a beaker? So to RATATAZ something is to ask a question, read a little bit about beakers. So let's read the text. A beaker is like a cup with no handle. It has lines on it and a little spout for pouring. The lines on the beaker are used for measuring liquids like water, milk, and soda pop. So take a close look at your beaker, flip it over, look at the little lines, look at the spout. That's a beaker. What is a graduated cylinder? So grab the graduated cylinder. A graduated cylinder is like a very tall, skinny beaker. It holds liquids. It has lines on it, so take a peek at those lines, and a little spout for pouring, just like the beaker. A graduated cylinder is used to measure liquids. It is called graduated because of the marks used for measuring. So these are the marks used for measuring, and that's why it's called graduated. Okay, what is a transfer pipette? So go ahead and open your transfer pipettes. I'm going to take my scissors out and I'm just going to open those to use, and if you can just take your transfer pipette and just clip the corner off and pull one of those transfer pipettes out. Okay, so grab a transfer pipette. A transfer pipette is a thin tube with a bulb on the top. A transfer pipette can move small amounts of liquid from one container to another when its bulb is squeezed and released. Cool. All right, what is a test tube? So grab your bag of test tubes and let's open up the test tube bag. And let's take one of them out. A test tube has many uses for holding liquids, powders, and small items. A test tube with a cap allows you to shake it and mix things together, and the cap also helps to keep things from spilling. So here's a test tube. So why don't we just go ahead and take all the test tubes out and put them in the rack. There are 5 slots. I'm gonna go ahead and stick those in the rack, like so. And we're gonna use these in just a minute. Okay, what are milliliters? So if you look very carefully, pick up both the beaker and the graduated cylinder. You can see this little ml there. You can see that right there written at the top. That stands for milliliters. So what is a milliliter? That's a great question. Scientists measure liquids in milliliters instead of cups and ounces. Your beakers and graduated cylinder uses milliliters for measuring. So this one, the beaker also has fluid ounces on it, but most scientists, even American scientists, use the metric system or milliliters to measure things. So a milliliter is a measure of volume, okay? Measures liquids. All right, so let's practice making your own questions about beakers, graduated cylinders, and pipettes. Here's some help getting you started. So again, asking questions about graduated cylinders or beakers or pipettes or test tubes. This is the way you learn about these things, okay? So let's ask some questions together, and then I want you to ask your own questions. And if you're not big on writing, that's okay. You can just say your questions aloud, and if you have somebody nearby, just hire them as a lab assistant. You're the scientist. Get the lab assistant in there and have them write the questions for you. Turn the page now that we have our questions asked. The next step is to tinker, test, and try. So that's part of ratatazing. We've read a little bit about chemistry. We've asked some questions about chemistry and the tools of chemistry, and now it's time to tinker, test, and try. So put a beaker and the graduated cylinder next to each other on the table. So do you notice something kind of funny about the beaker and the graduated cylinder? They both hold 100 milliliters. They both have 100 at the top. Wait a minute. Are you telling me that the beaker and the graduated cylinder hold exactly the same amount of liquid? Are you sure? Do you believe it? Do you believe that these hold the same amount of liquid? Well, the great thing about science is that we don't have to believe it or not believe it. We can test it. So let's give it a test. So what's the next step? All right, find the line marked 100 milliliter on the beaker. So grab your beaker and find the mark 100 that says 100 near the top of the beaker. And fill this beaker with the water up into the line. Grab your water and fill it to the 100 mark, best you can. One of the things that chemists do is they hold this up to eye level. It's a little tricky because my hand moves a little bit, but I'm going to hold this up to eye level like this, and I'm going to see, is that close to the top? Is that hitting the 100 mil mark? Yep, looks like it is. All right, what's the next step? So I'm going to think about pouring this into the graduated cylinder. And what do you think? Where do you think it will go? So ask some questions. How far do you think it will go up? Do you think it will go all the way up to the 100 milliliter mark? Do you think it'll go halfway? Do you think it will go past the 100 milliliter mark? So let's test it. We're going to pour the water from the beaker into the graduated cylinder and see where it ends up. Wow, it filled the graduated cylinder. Not only did it fill the graduated cylinder, but at least in my case, it went past the 100 milliliter mark. It holds more, the way that I poured it, holds more than 100 milliliters according to the graduated cylinder. So wow, that's kind of interesting. So I'm going to say that the water filled the graduated cylinder. So what happened? You can mark the water filled the graduated cylinder and it overflowed the 100 ml mark. It went past. I'm going to say that the water went past the 100 milliliter mark. So wait, what do you see? Is it the same or is it different? Did it measure exactly 100 milliliters or not? Well, it's not the same. All right, it is more. So I'm going to mark no, it's more. So that's what I saw. In my experiment, I got more water in the graduated cylinder. So to fix this problem, chemists use a trick, also called a technique, to get the top of the water to line up exactly. Okay, so take one of the transfer pipettes out of the bag, and we're gonna use what's called a chemistry trick or technique. We're gonna refill with water just below 100 milliliter line. Okay, so what I'm gonna do is I'm gonna take the water out of the beaker, I'm gonna pour it very slowly into the graduated cylinder. And I'm gonna pour it just below the 100 milliliter line. So I have a little bit of liquid just below the line. The next thing I'm going to do is take some more water and I'm going to use the transfer pipette. It says stick the pointy end of the transfer pipette into the water in the beaker. Squeeze the bulb, so take the transfer pipette, squeeze the end of the bulb, hold the end of the bulb squeezed together, put it in the water, and then suck up some water into the pipette. Then I'm going to place the pointy end of the pipette into the graduated cylinder and squish the bulb to put more water in the cylinder. So this allows me to add just little bits of water to my graduated cylinder, and I'm going to actually put my tip along the side of the cylinder so it will fill nice and smoothly. And you can see I'm filling up the graduated cylinder. I'm going to need a little bit more water. Until you get right to the top. And there's more techniques we could talk about when using graduated cylinders, but I think that's enough for today. All right? So what I'd like you to do is to try a challenge. I want to see if you can pour 50 mils of water in the graduated cylinder, or pour 20 mils of water in the graduated cylinder, or pour 10 mils of water in the graduated cylinder, or measure 5 mils, and use the trick. So let's practice. I'm going to do 50. Just below the line, and you do this with me. And then take the pipette bulb, fill up to 50. And remember to try to get that line at eye level, and you can see the top of the water. I got it exactly at 50. How about I try the 10? I'm going to try 10. Oop, that's harder. That went faster. My pipette. Right there at the top of the line. There we go. Pretty good. Pretty close to 10. All right, so that is how to use a chemistry trick to fill a graduated cylinder if you really want to try to get an exact volume. Okay, what's next? Test tube skills. We're gonna have some fun here, but let's grab your watercolor paints and actually take out your brown paper and put it on the table. And let's open the watercolor paints. If you have scissors or if it tears pretty easily, we're gonna open up the watercolor paints and look at all those pretty watercolor paints. But we're not actually going to paint anything with watercolor paints. We're going to break them up. So flip the little container over and all the watercolor paints should sort of fall out. We're going to take the test tubes. We've already put them in the test tube holder, but if you haven't done that, go ahead and take your test tubes and go ahead and remove the caps. So we've got our test tubes with no caps, and we've got all our little watercolor paints on our brown paper. Okay, what's next? So flip the page. Oh, it says at the last line, it says find the red one, the yellow one, the blue one, the green one, and the orange one. And then move the other three aside for a moment. We can use these later, you can play with them later, but let's take these watercolor paints. These are the ones that we separated out. And let's flip the page. All right, next what I want you to do is use your scissors that we use in the starter kit and just cut. These cut pretty easily. I want you to break them up and just make some pieces. So cut the watercolor paints with the scissors. The smaller the pieces, I think the better. Try to get them to stay on the paper, like so. All right. We're going to cut red pieces. I'm going to cut yellow pieces. All right. I'm going to cut the blue pieces. Green pieces. And finally the orange pieces. So get them cut into little teeny pieces. And the next thing we're going to do is put the pieces into, each of the pieces into its own test tube. So grab your test tubes, pull one out, and then stick some of the red pieces inside that test tube. And you don't have to put the whole thing in there. You can just put part of them in there. So red, yellow, blue, green, and finally orange. You can also play with these little pieces. You can break them with your fingers instead. You don't even have to use the scissors. Oh, it's fun to use the scissors. Okay. So now we have all of those colors. What's next? Now that you know how to use the graduated cylinder, use it to add 10 mils of warm water to each tube. Okay, so this is a chance for you to use your skills. So grab the graduated cylinder and see if you can pour 10 mils. It's really at the bottom, it's a little bit tricky. Use your skills and pour 10 mils into the cylinder. You can use the trick. And then pour that 10 mils into your test tube, like so. And stick it back in the holder. Do the next one. Okay, now that you have all of the paint and the water in your test tubes, go ahead and put the caps back on, screwing them down. You don't have to screw them too tightly, just finger tight. Screw them down on your test tubes. All right. Now the next part, I'm going to go ahead and move my paints over so I don't get the little chips on me. I've got paint in my test tubes and water in my tubes, and what I need to do is shake them. If you have warm water, they'll dissolve more quickly, but shake them until you start to see color coming. So go ahead and just shake them up and just shake them all. Get some nice color going. That's why I like to have tubes with lids on them, so I can shake things and it doesn't spill. So you mean tapping? I'm tapping the table with it. That helps tap the paints down. Anything you can do to get them to shake, to dissolve. The paint is dissolving in the water. You can see the color starting to come out. All right, so now shake these up The more you shake them, the deeper color they will become, the more paint. The paint doesn't have to melt all the way, but try to melt it as much as possible, or dissolve it as much as possible. All right, I think we have enough color in these to do the next step on the experiment. Okay, so what's next? All right, replace all the caps. We've shaken the tubes. There's some solid left at the bottom. Okay, tinker, test, and try. All right, so this is a question that we are asking you to try. What will happen if you pour half of the blue water into a beaker and then add half of the yellow water? So what do you think will happen if you add blue and yellow? You get a different color? Let's try it. So I'm going to take the blue, I'm going to pour half of it in here. And you have to be careful pouring it all out. You can see it's pretty easy to pour all of it out, but that's okay. You can always add more water back. And I'm going to add the yellow. I'm going to pour half of the yellow in there. And then I'm going to pick up the beaker and I'm just going to swirl it like this. I'm going to start to swirl it. Is it changing color? Do you get green? So here's a sciencey question for you. How do you know if you have green? I mean, it looks a little green, but one of the ways you can tell if you have green or how green your green is to compare it to the green paint. Okay, so this is very green. So take the green out and compare them. How close are you to green? If I put them over the white of the lab notebook, I can see that this green in the beaker is a little bluer than this green. So are they the same color? I would say sort of the same color. So let's mark sort of. And then it says if you answered no or sort of, try adding more of the yellow or the blue to see what happens. So I think I need to add a little more yellow to this to make it more green. So I think my green is too blue. Let's see if that makes it a little bit more like the green in the tube. I think it's getting closer, but I would add even more yellow. That's a lot of yellow. And I suppose I could add too much yellow and it would be too yellow. But I think that's getting actually pretty close to the green in my tube. It's pretty close. So if you have a question, like, can I make green out of yellow and blue? All you need to do is test it. So let's try another one. What will happen if you pour half of the red water into a beaker and then half of the yellow? Oh, but you know what? We're all out of yellow because I used the yellow, so that's okay. What I'm going to do is I'm going to pour more water in the yellow because there's more paint in the yellow one. So not to fear, we have more yellow we can play with, because we didn't dissolve all the paint. Shake it up a little bit. Get some nice yellow in there. So we want to add, it's yellow and red. So what color do you think yellow and red will make? Any guesses? Well, let's try it. Let's do yellow, half yellow. And then half of my red. I'm going to make my red a little redder. And then I'm going to mix it. And what is the color that you get? Is it orange? Well, I can say it's orange, but what I can also do is compare it to a color that I know is orange. This is like, it's called using a control. In other words, I'm comparing it to something that I know is already orange, and I can get a better idea of how orange my orange is. So I'm going to compare it to the orange in the tube, and I would say it's a little too red. So I'm going to tinker with it. I'm going to play with this. This is all part of being a scientist. I'm going to add a little more yellow to see if I can get this a little more orange. You can see, yep, it's getting way more orange. That's looking very nice. It's looking very orange now. It's almost the same color as the orange in the tube. So, with this little experiment, we got to play with some colors. We got to prove to ourselves that we could make green and orange out of mixing different colors. And we also got to practice using our new technique and using the graduated cylinder. Okay, so on your own, I want you to play like a scientist. You have other colors here. You have more colors in these test tubes. I want you to mix different colors. So on your own practice, play with different colors. How can you get black? Can you get turquoise? Could you make brown? What other colors could you make with these colors? All right, so the next section is ask your own questions. Okay, back to the questions. So we've been practicing asking questions because, again, asking questions is the way you actually learn something. It's not by doing the experiment or reading a book. It's by asking questions about the experiment you're doing. It's asking questions about the book you're reading. So let's ask some more questions and use words like how, why, where, is, does, can, when, what, or what to start your questions. So as an example, a question is, can I make my own watercolor paint? Or I would ask a different question. I would ask, how can I make my own watercolor paint? So spend a few minutes and ask some questions about the colors, about anything that was in the reader, about any chemistry question you have. It doesn't even have to pertain to what's in what we did today. That's the way to RATATAZ, is just to start asking questions and reading some more. Okay, so finally what I want you to do is pick your favorite question and circle it. So my favorite question is, how can I make my own watercolor paint? The next part is where you look at the question you circled and you try to answer it on your own. In other words, you try to find the answer. My question is, how can I make my own watercolor paint? Do I do an experiment? I could call another scientist. I can go to the library and read about making watercolor paint. I can do a Google search, finding out how to make watercolor paint. I could go on a field trip, maybe to a paint shop or a paint store or a place where they make paint to find out more about how paint is made. So what I want you to do with your favorite question is see if you can answer it. And finally, talk, tell, and dazzle. The last part of the RATATAZ method is to talk, tell, and dazzle. In other words, share what you discovered. So I'm going to go home, I'm going to do a Google search on how to make watercolor paint, and then I'm going to figure out how to make my own watercolor paint, and then I'm going to record a video, and I'm going to share that video with you. So I want you to do the same with your question. Try to answer it and record a video. You could write a report, you could create a play or make a drawing, and then using the hashtag RATATAZZLE, share your discoveries on your favorite social media. And that's it for the chemistry box, What is Chemistry? For the RATATAZ box, What is Chemistry? Thank you very much, and I'm excited to do the next box with you. Let's RATATAZ.